Hey, what's going on, guys? Let's do this problem right here. The first question is asking a horizontal wire carries a current straight toward you. From your point of view, the magnetic field at a point directly below the wire points is where? So here they are asking for the magnetic field's direction. So here what we had to do is we had to take our right hand and point all our fingers toward the direction of the current. And if it's toward you, right? So you point all your fingers toward your direction and you curl it. When you curl the direction, that's going to be the wherever the points are showing, the direction of the fingers points is going to be the direction of magnetic field. And when you curl this one, it's going to be right side, right? So the direction of the magnetic field is going to be to the right. So that's how we find the direction of the magnetic field. So this is going to be to the right. And let's do the next problem. Next question is asking a charge is accelerated from rest through a potential difference and then enters a uniform magnetic field oriented perpendicular to its path. The field deflects the particle into a circular arc of radius. If the accelerating potential is tripled to 3, what will be the radius of the circular arc? So here what we have to do, we have to find the proportionality between the radius and the potential difference, because we are going to see what's going to be the new radius when this potential is tripled, right? So we have to make a proportionality between radius and potential difference. And whenever you have a potential difference question in magnetic field equation, you can think about this one. That's energy equation. So energy is equal to Q times V, right? And also energy is equal to, like, energy is a moving particle, right? So energy is going to be kinetic energy right here. So kinetic energy is going to be half mv square. So from this one you can equate these two and find the proportionality between velocity and this potential difference. Then you can connect with the radius. So here let's find this one in terms of velocity and see what we get. So let's equate both of them. So this is going to be half mv square is equal to qv. This v represents potential difference and this v is for velocity. And let's find the velocity using this one. V square is going to be equal to 2qv divided by 2, and also it's multiplied by 2, we already multiplied. 2qv divided by m, and that's going to be then if we find v, that's going to be a square root of 2qv over m, right? So this is velocity equation, and since this is in circular motion, there's going to be a centripetal force. Centripetal force is given by Fc is equal to mv square over r, and then also this is due to magnetic field. There's another equation, that is F is equal to qvb sine theta, but sine theta is going to be 90 degree because this is perpendicular, right? They mentioned that magnetic field oriented perpendicularly to its path. So this is 90 degrees, sine 90, that's going to be equal to 1. So we don't have to worry about sine theta because we are going to substitute 1 right here. That's going to change this equation into qvb. Now all we have to do is we have to find the relationship between radius and the velocity. So let's equate both of them. mv square over r is equal to qvb. So here we are trying to find the radians relationship. So we are trying to find r, right? R is equal to mv square over qvb, and here v and v square cancels. We are left with mv over qb, and this is the relationship between r and mv qb. This v is velocity, but we want the we are trying to find the relationship between radius and the potential difference, right? We want the proportionality. So what we can do right here is we can plug the V value we found out in terms of potential difference to this V to find out the proportionality between radius and the potential difference. So let's go ahead and do that right here. So here if I write velocity in terms of potential difference, this is going to be R is equal to m over qb, and now I am replacing this all v with this value. This is going to be square root of 2qv, capital V is potential difference, over m, right? Now we don't have to worry about anything else except potential difference, because we are trying to find the change due to potential difference in the radius. So here, if we find the radius and potential difference, R is directly proportional to square root of V, right? According to this equation. Now we can see what's going to happen if we triple the potential difference. If we triple this one, this is going to be, let's say this R naught when we don't change anything. This is when we triple the potential difference. So when we triple the potential difference, this is going to be square root of 3V, right? And we can also write this one in different way, like square root of 3 times square root of V. Now we replace this square root of V with R naught. R naught is equal to square root of V, so we can replace this R naught with square root of V. So R prime is going to be equal to square root of 3 R naught. So the relationship is going to be square root of 3 R naught. So that's going to be the answer. What will be the radius of the circular arc? And the new radius is going to be square root of 3 times the old radius. So this is going to be the final answer for this question. I hope you guys find this video helpful. See you next time.